Hello. In the previous class, we had learned to identify whether a sentence is a statement or not a statement. And we could identify very well statement and not a statement. As we take the chapter further, we will come across to only statements. We will never see a sentence which is not a statement. We will always learn and come across to statements. Today, we have a topic, compound statements. You have learned this earlier in English also. A statement joining two simple statements is called a compound statement. The same thing applies in mathematical logic also. Check the first statement. Mumbai is in England and London is in Maharashtra. This is a compound statement. You can clearly identify two simple statements. Two atomic statements also you can say. You can use a scientific word atomic statement or a normal English word simple. Two simple statements makes one compound statement. This is a compound statement. I would like to show you the two simple statements. The first is Mumbai is in England. Yes, we know very well if it is a statement, it can be true or it can be false. Whatever it is. We are not at all bothered or we have to not matter about that. Whether it is true or false, which is a statement. The second statement is London is in Maharashtra. I know this is a false sentence. Of course, if it is a false sentence, it makes a statement in logic. Let me denote them in symbols. Let the first statement be denoted by small letter P. Let P colon, that is called is, B, Mumbai is in England. Let small q be London is in Maharashtra. So basically these are all compound statements. What we have to do with these compound statements? We just have to write them in symbolic form. This is how I am going to write them in symbolic form. This is P, this is Q. And for the first time you will see the symbol of the word AND. In maths, the symbol of the word AND. In mathematical logic, the symbol of the word AND is this. Yes, the reverse of V, the ulta V. This is the symbolic form of the given statement. So basically today what are we going to learn? We are going to study, we are going to write all the compound statements in symbolic form. To make our work easy, I have chosen the same type of statements with different connectives. They are called connectives. Here and is the connective, here or is the connective. Here if then is the connective. Here if and only if is the connective. Here I know you cannot see any connective, but we have a special connective in mathematical logic. Very strange, but yes, it has got a special status of connective in mathematical logic. Not. The word not is a connective for us. Before we start, the second, third, fourth and the fifth, we can definitely revise the first statement. Mumbai is in England, London is in Maharashtra. The same assumption can be done for the next statements also. Let P is this and Q is this. What you can write. The symbolic form of the above statement is P, Q. P और Q के बीच में क्या है? और. Yes, this symbol is for OR. Let us work out the symbolic form for the third statement. Let P is, Q is. You very well know what you have to assume, what you have to write. Let P is, Mumbai is in England. Let Q be, London is in Maharashtra. The symbolic form of this, P, Q. If then is a connective. The symbol of this connective in mathematical logic is this arrow. This arrow is read as implies. This arrow is read as implies. Without wasting time, let us finish. Let P be London, Mumbai is in England. Let Q be London is in Maharashtra. The symbolic form of this compound statement is PQ. Can you see 2 times if and only if? This is the arrow used for it. If you remember, of course we will revise once again. This symbol is read as implies. Double implies. And the last but not the least, Mumbai is not in England. We assume let P be, Mumbai is in England. And the symbolic form will be, it is only one statement. Still it has got a designation of a compound statement. It has a connective in it. This connective not is expressed by a symbol which was earlier seen in similarity. This is called negation P. We will revise, we will read, learn the names of all the connectives. But for the time being, you have to understand how to express it in symbolic form. These are the few examples, these are the 5 examples where you learn all the 5 symbols, the only 5 symbols to express in the symbolic form. Please go through it. Let us understand, learn and remember the topic today called connectives. Connectives are symbols, are words which combine 2 simple statements into a compound statement. In maths, in the chapter logic, mathematical logic, these are 5 connectives. We also call them as logical connectives. These are the 5 symbols, what you see, will be used as connectives. This, if you recall, will be used for the word like and, but, though, although, etc. This symbol is used for the word or. This symbol is used for the words if, then. This is the symbol used for the word if and only if. This is the symbol used for the word not. This symbol, these words in mathematical logic are termed as conjunction. The compound statement is a conjunction. These connectives are called conjunction. This type of connectives are called disjunction. This connective is called conditional. This is called biconditional. And this symbol is called negation. This singular word you can see, if you recall, I had used the word implies. You can also read it as implies rather than using the word conditional. You can use implies. Here you can use double implies. This is also known as double implies. Please do not use your brain and do not think of using a word similar to. No, this is not geometry. This is a summary of logical connectives. In fact, it is a detailed explanation of the logical connectives which you will come across in this chapter. Please go through this. Continuing the topic further, compound statements and logical connectives, or you can say logical connectives. Today's question is again, express the statements in symbolic form. We have learned it earlier, we are going to revise it today once again. The first compound statement, Bhavik sir is an actor. Yeah, it is a statement. I know it is false. And Priyanka Chopra is a teacher. Whatever, true or false. Their statement, they will be denoted by small letter P. Let P is Bhavik sir is an actor. Let Q is Priyanka Chopra is a teacher. Yes sir, we know how to write in symbolic form. P and Q, these are two statements which are combined. We can see the connective and. We have learned the symbol of and. This is a conjunction and we write this way. This is the symbolic form of the given statement. The next statement, of course, one can be ready with P and Q. But before I start assuming P and Q, I would like to read the statement. If Bhavik sir is not an actor, then Priyanka Chopra is not a teacher. Very important. Very important to understand. Let P is. All of you must be thinking, let P is Bhavik sir is not an actor. The assumption should never be negative. In our assumption, the statement must be always affirmative, positive. So P will be Bhavik sir is an actor. Let Q be the statement where Priyanka Chopra is a teacher. We cannot assume a negative statement as in symbol. We have to assume a positive statement, affirmative. Well, the symbolic form will be, of course, when we see if then, we will definitely use this symbol which is called implies. Of course, between P and Q, but why it is important? Here, I have assumed it affirmative, but it is a negative statement. So I have to use the symbol of the word not. Here not, and here also not. So this is the proper symbolic form. Remember, in your assumption, there should never be the word used not. Third and fourth. Here you find though. Wherever you find though, but, also, they all belong to the category conjunction. Conjunction meaning and. This is very simple. you can assume on your own. Let P is Bhavik sir is an actor, let Q is Priyanka Chopra is an actor, and the symbolic form will be P and Q. P and Q, though has the same meaning like and. The fourth statement, let P is Bhavik sir, a teacher, let Q is Priyanka Chopra is an actor. This is the connective. Yeah, IFF is called as if and only if. This is read as if and only if. And if we recognize if and only if, then we know how to write in the symbolic form. The symbolic form will be P, Q. Of course, there is no not sign, there is no negation. If and only if is shown by this symbol called double implies. With my examples, with my today's lecture, every one of you can easily solve the textbook sums, which are, of course, definitely different from my examples. So what you need to remember to understand today's lecture properly. If you have not understood, you can revise it once again and put it in your brain. And I am very sure after learning this and remembering this, you will be able to solve the textual exercise having the same set of questions. Please go through this.